Hello, everyone. Good morning, afternoon, or evening. Dear authors and invited guests, welcome to Technical Session 6B. My name is Alisha Mullah, and I will be your moderator for this session. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Sustainable Development, ICT4SD 2026 in Goa, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Goa, and the virtual event is being held from 9th to 11th July 2026 via Zoom. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 10 presentations. Each presenter will be given 10 minutes for presentations and 2 minutes for question and answer. On the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay connected with us till the closing remarks. If you have any query or update, you can write it to me in the chat box. Before we start the session, I would like to introduce you all to the chair for today's session. Dr. Shafi Pathan is the principal at Anjuman-e-Islam's Ahmed Sabu Siddique College of Engineering, Mumbai, Maharashtra, India. With 24 years of academic experience, he has authored 5 books, contributed a book chapter, and presented 39 plus research papers in national and international journals and conferences. His research interests include machine learning, deep learning, Internet of Things, network security, and information security. Unfortunately, Dr. Pathan is facing some technical issues and he'll join us within the next 10 to 15 minutes. But without any further ado, we shall begin with the conference. The first presenter for today is Kesalai Shakla, who will be presenting a refined MobileNet V2 framework with enhanced feature aggregation for accurate multi-class plant leaf disease recognition. You may now begin your presentation.
So, hello everyone. My name is Kisla Sukla, and I'll be presenting you with my paper, which is, I hope now that you can see my paper.
Yes, we can.
Okay. So the paper is a refined MobileNet V2 framework with enhanced feature aggregation for accurate multi-class plant leaf disease recognition. So basically, the motivation of the paper was from that our 40% of the crops are I mean, we lose 40% of our crops due to diseases in the leaves of the plants. In daily basis, I mean, in farms, you can see that the different type of diseases are. I mean, you can see them everywhere. So I had a plan that I had an idea that I should develop a model that can recognize the diseases in early age. So there was some models on these topics. So I have studied them. There was some SVM, decision trees, and ANN based models. And I decided to use deep learning. And there was also some ResNet, efficient net, mobile net V2 models. So I have studied those also for the basic structure of the model. So the data set that I have used was it was plant village dataset. It consists 83,000 images, where we use approximately 70,000 images for the training purpose and 17,000 images for the testing purpose. So what I did is that I also use data augmentation, and what we do in augmentation, we do zoom, transmission, brightness adjustment, and all those things, horizontal and vertical flip, so that the variance would not be there in the data. There should be uniformity and data should be clean. It was a refined data set from initially it was a refined data set, so I don't have to do all those pre-processing. So this is a basic mobile net v2 architecture. Here you can see that we do here in these types of architecture, we use convolutions instead of the whole plane. What we do is that we take the neurons to the depth of a plane. Okay. So what I did is that I have unfreezed some layers, like approximately I have unfreezed 10 layers from this model. It consists approximately 56 layers, MobileNet V2, And I have also added global average pooling, dense layer, dropout layer, and softmax output layer for the output. So what I did is that I have designed that architecture. So the total parameters were 29, 2 million and 93,000, 29 million basically. So trainable parameters were 2 million, and the frozen parameters were 7,000 and 32K. Model size was approximately 10 MB, which is, I mean, a very lightweighted model, because when we see the models in this field, they are approximately 20 MB, 30 MB in the size. So our model was very lightweighted. Okay. So these were the training performances. This shows the accuracy and the loss in the training process. I've achieved 98.67% approximately accuracy training this model. So I have used accuracy, precision, recall, F1 score, MCC. I mean, these are all standard matrices that we use to evaluate the performance of any model. So it was the AUC score, where you can say that the score of. So the problem was that I have to divide the leaf into 38 classes. So here is the AUC score of each class. Here you can see uh, the the confusion matrix. The diagonal value is high, and there are very some variances in between. Okay. So the model performance was, I have achieved 98.87 accuracy. The precision was also high. Recall was 98.3. MCC and ROC scores were also very good. I have also compared this with some existing model like MobileNet V2 that I had with the ResNet 50 EfficientNet B0. And the best thing was that the parameters that we use, trainable, were very less compared to other models. So it proposes a MobileNet V2 based Lightweight deep learning model for the deep plant disease classification. It has achieved good accuracy, but I have forgot to add future work. We can also use VIT, Vision Transformer, for the further research in this area, and yeah, that will be good. So that was from my side. Thank you, guys.
All right, thank you so much. We'll now move on to the next presentation. You may now stop sharing your screen.
Okay.
All right. So our next presentation for today is by Utkarsh Tiwari, who will be presenting a streaming graph neural network framework for real-time multi-class cyber threat detection. You may now begin your presentation.
Good afternoon, everyone. My slide is visible to all of you.
Not yet. Excuse me, Utkarsh, could you please share your screen? Right. We'll circle back to Utkarsh in a little while. We'll move on to the next presentation in the meantime.
Just give me a second. I'm just trying to connect the device.
All right. Okay. No worries.
Hello. Hello. Hello.
Yes.
Yeah, this is Shafi Pathan.
Oh, okay. Yes. Welcome.
I was not able to join at that time, but I joined right now.
All right. Welcome, sir. We just finished the first presentation. The second presentation will be now.
Acha, fine. Okay, I'm there, ma'am.
All right. Thank you, sir.
I'll listen.
I will disconnect and bring just 1 second.
All right. In the meantime, we'll move on to the next presentation. We'll circle back to Utkarsh. So our next presentation for today will be by Shashank Parmar Yogendra Meera, who will be presenting Artificial Intelligence Between Justice and Crime, a review of opportunities and legal limitations. You may now begin your presentation.
Hi everyone, I'll just present my screen. Is my screen visible?
Yes, it is.
Yes. So my paper is on artificial intelligence between justice and criminal. It's a review between the opportunity and the uh, legal limitations. So as we begin, the same artificial intelligence what we use, which helps police department to predict criminal hotspots, have also helped criminal to organize their network and generate a lot of synthetic identities overnight. So these are the few of the things which it strengthens the justice, and the same AI also gives edge to the armed criminals. So prediction of hotspots, real-time forensic interpretation, AI assistance, sentencing support, machine learning, transaction monitoring, and cybersecurity threat detection. And other part, it is also helping our criminals to be more techful and also have deep fake synthetic identity, automated fraud at mass level, AI scripting, publishing in 100 plus languages, in instant money laundering cases, and crime as a service platform. All these examples which have been given are all documented, and the same tool is serving two sides of the good and bad. What is this study about? It's about construction role, criminal exposure, and legal social limits. So we will be covering all three aspects as an objective, and one by one I'll explain it further. AI strengthening criminal justice. So machine learning can help police investigators and also help us in our national security to detect, to analyze the data which is already present with the authority on a real time. Right. And forensic investigations, which happens on real times, wherein you can survey, collect evidence. Also, use of drones and AI has been recently documented in our Indian festivals, which has also helped our authority to manage the crowd control. Court supports AI assisting judges, which doesn't mean that they are replacing judges, but they are just assisting judges to get to a relevant case laws, and also to make sure that they have a guidance to sentencings of that particular matter. Financial crime, machine learning, transaction monitoring, detecting money laundering patterns at the volume and speed no human analysis can match. So there are a lot of AIs which have been already been placed in multiple countries, which helps to detect the patterns of money laundering and all. And cybersecurity, of course, AI powered threat detecting, integrating responding system, and defending critical infrastructure in real time. Next, we'll go to criminal justice system. Virtual AI has always been a part after the COVID-19 pandemic, which the world faced. So AI drives the digital courts, reduce delay, increase access to justice across the jurisdiction. This is happening in multiple countries, wherein the AI is playing a very important role to do e-filings, e-litigation, risk analysis tools, machine learning assist bail decisions, also sentence rapidly, more fairly questions, helping judges to understand the matter properly and also to fetch relevant case laws to come to a decision of a fairness. Algorithm based bias is there, of course. It is, if it is the data is not given properly, it will create an issue, but at the same time it will also give the judges and the judiciary system a head start, and help them reduce the burden which they are already facing. uh, yeah, so how serious this is? Yes, it is very serious. $40 billion dollars currency transaction in 2024 as per the Interpol 2024 reports. Criminal network active in 2 to 7 countries. 3 minute it takes time to commit an AI crime. Synthetic identity by one operator can be generated. Deepfake bypass all your KYC, voice recognition, also your it also helps to impersonate you. One operator can do multiple tasks all the because of AI, which is cutting into a more systematic thing where the speed at what they can do, it cannot be done by human. And also whom do we punish? That is the major issue which I have also addressed in my research paper. So what do we have right now? First of all, we do not have anything concrete wherein we can say that who will be punished in case a crime is conducted by a AI, the developer, the person who is operating it, or the AI itself. AI itself cannot be done because there's no real person involved. Jurisdiction problems are also there if the crime is committed in country A and the system is in country B, the monies are moving by country C, and the D is the principal. So there will be no limit. There will be no jurisdiction which will be able to take action on only one part. All the jurisdiction has to come and together create a framework which is there in Budapest Convention to come and come to one platform and try to find the criminal. The AI Act, Information Technology Act of India, was created in 2000. It's now 25 years old. It requires some amendments. Also, BNS, it's a very good move by Indian government to put BNS Section 111 as a criminal, cyber crime, but definition is nowhere there, so that has to be changed. These are the observations which I have put into my papers and recommendation. One is adequate legal framework, ethical designs at source, interdisciplinary collaboration, international cooperation, continuous capability building. This will help us to monitor the AI and come to a place wherein the AI is used in a transparent and good ethical way. AI is a mirror of the choice we made it governing it, opportunity, threats, and the answer. So the opportunity is that it offers a huge amount of power to an individual. Threat is that it can be used on good and bad, and the answer is we need to combine it. Thank you.
Dr. Pathan, do you have any questions? In case there's no questions, we will now circle back to Utkarsh's presentation.
Ma'am, I do have one question.
Yes, please.
Yeah.
Yes, sir.
Yeah. Is there any case studies which shows that AI has been used in the justice system?
Yes, so there is a paper wherein it has been used by
Any published case studies, I'm saying.
published case study. So it's there in Singapore, one of the case study.
Achha. Okay, fine.
Yeah.
Okay, it is all from my end.
Thank you, sir. Thank you, everyone.
All right, Utkarsh, you may now continue.
Okay, am I audible?
Yes, you are.
Okay. Good afternoon, everyone. Marshall Abhijit, along with my respected teacher Utkarsh sir. Today I am presenting my research titled A Streaming Graph Neural Network Framework for Real-Time Multi-Class Cyber Threat Detection. Actually, this work proposed a real-time extension detection and response framework by combining Graph SAE and off-eating tree. Now, in the introduction part, nowadays, as we know, organizations generate huge amount of security data from endpoints, networks, cloud services, and applications. Traditional security solutions like firewalls and antivirus software cannot effectively detect sophisticated cyber attacks. So, although the extended detection and response, or we can say XDR, integrates information from multiple security sources, many existing XDR systems rely on batch learning and cannot adapt to continuously arriving data. So there is a need for an intelligent, adaptive, and real-time threat detection framework. So our proposal is to develop a such kind of systems that can continuously monitor our system. So as we know, the main, actually, we can say the main goal of this work is to adopt a real-time XDR framework. Now, why we choose this type of topic? Because as we know, I have already told in the introduction, nowadays the dependencies of XDRs is offline or batch machine learning. They cannot continuously predict and prevent. Some of them is obviously some of are present, but not accurately not accurately detect on and response. So to achieve this, we model network entities using dynamic graph and apply graph SSG to capture contextual relationships. Then we use a half-adding tree classifier to perform online learning without retaining. So our objective is to develop a real-time XR framework to continuous cyber threat monitoring, model relationship among user, host, service, and network flows using a dynamic entity graph, and enable continuous online learning without frequent and model retraining. Next slide, please. In the paper, we have mentioned many past work, but these are some very famous and absolute work. First one is the Giorgio. The author actually introduced MXR for improved threat visibility. As you can see, the Mukherjee, Mr. Mukherjee proposed an explainable GNN framework. After that, as you can see, the most existing methods either require a batch learning or have a high computational complexity. So this motivates us to design a lightweight streaming framework capable of continuous learning. Next slide. So in our proposed methodology, first step is data preprocessing. But first, I want to say about dataset. Actually, we have used UNSW NB dataset. Now, this dataset contain actually 1,75,341 training samples with 49 features. Including 10 attack categories such as DOS attack, exploits, reconnaissance, fuzzers, backdoors, worms, and normal traffic. To simulate an XDR environment, actually we have added contextual information such as user ID, host, and service ID. Normally, the original record contain protocol, service, state, S bytes or D bytes. But for a real-time environment or XDR environment, we have added extra information. In the second step, that is our category encoding. After that, first we pre-process the dataset by cleaning the data and adding the three contextual fields. After that, we all categorical values such as protocol, service, state, user ID, and host are converted into numerical values using label encoding. These numerical representations allows machine learning model to process the data efficiently. Now, after encoding, we construct a dynamic heterogeneous graph. As we can see in the image, each network flow becomes a node. Additional nodes represent the users, host, service. Edges are connected similar network flows and shared entities. This graph actually captures both behavioral and contextual relationships. Next slide. Now see, as you can see in the diagram, in the PP slide, current flow is flow 25. And suppose the flow neighbor is flow 24 with user C, host 1, HTTP. So the total nodes will be 5. So edges will be connected like flow 25 will be connected flow 24, flow 25 will be connected with user C, flow 25 will be connected with its host 1, flow 25 will be connected suppose HTTP 1. Like that, our whole graph will be constructed. After that, the graph after encoding, after that the graph SSG generates a graph embedding. Actually, instead of considering only the current flow, graph SSG aggregates the information from its neighbor. Actually, in the number of amount the information we have, basically it improves our training. So the graph also collect information from its neighbor. This enable actually the model to understand both individual and behavior and surrounding context. Next slide. Now, after that, this is the main, actually main unique in our paper. Actually, here we have introduced a half-ending tree classifier. Actually, these graph embeddings are passed to half-ending tree classifier. Unlike traditional machine learning models, the half-ending tree actually process one sample at a time without retaining the whole model. It predicts the attack category and immediately update itself. It does not take too much time. It instantly predict the attack category or automatically update itself. Therefore, the model continuously learns without retraining. So this is the benefit of our proposed model. After that, if a attack is detected, suppose the model predict and detect an attack, the framework generates an XDR alert. The alert actually contains the user ID, host, service, and predicted attack category. These are all in JSON files. Sir, next slide, please. Yes, this the JSON output will be like this. The JSON file will contain this user, host, service, and attack types. These alerts can be directly used by security operations centers for rapid incident response. This, as I have already told you, the alert contains the user ID, host, service, and predicted attack category. So it is very useful for any security operators to detect whether the attack is performed from where it's performed. Next slide, sir. In region analysis section, we evaluate our framework using streaming network traffic. The proposed model actually achieved approximately 99.9% streaming accuracy, demonstrating a fast and convergent and stable performance. As you can see, the F1 score remained around 0.50. Actually, it is mainly due to the class imbalance affecting minority attack classes. The threat detection graph also remains stable, indicating that the reliable real-time monitoring overall real-time monitoring. Overall, as you can see, the results show how that the framework is accurate, adaptive, and suitable for enterprise XDR systems. Next slide, sir. In future, as I have already told you, that the dataset imbalance. So if in future we will work in real-time dataset, as we have still right now used the traditional dataset, we are planning to use a real-time dataset, also improve the detection performance of minority and rare attack classes, integrating temporal graph learning to better capture evolving attack and behaviors over times. In conclusion, we propose a real-time XDR framework that combines graph SSE and Huffy ending tree. The framework actually effectively models relations among users, hosts, services, and network flows. It achieves actually high streaming accuracy while continuously learning without retraining. Therefore, it provides actually an effective and scalable solution for real-time cyber threat. So next slide. Yeah, that's my conclusion. The proposed system generates extremely entirely aware XDR alerts, making suitable for enterprise security, as I have already told. Overall, the framework provides an adaptive, scalable, and effective solution for real-time monitoring system. Next slide. So this is our references we have used in our paper. Thank you.
Hi, it is Shashank, na?
Utkarsh and Abhijit, sir.
Utkarsh. Achha. Utkarsh, you have considered threats different, isn't it? But have you categorized it? What are the different threats you have considered for this study?
Sir, pardon, please repeat again, sir.
What are the different threats you have considered for this study?
So for this study, actually, we can say, sir, actually categories means attack categories, and in threats are actually suppose hazards analysis, suppose backdoors, suppose DOS, exploits, generic reconnaissance. These are my main threat. Sir, I think you are mute.
Okay, good, Utkarsh. It is all from my end.
Thank you, sir.
All right, you may stop sharing your screen. Our next presentation for today will be by Bhagyashree K, who will be presenting Assessing ECU Vulnerabilities Through Bus of Attack Implementation in Automotive CAN Networks. You may now start your presentation.
Sure, ma'am. Am I audible?
Yes, you are.
Yes, you are.
Sharing the screen. Is my screen visible now? Like the
Yes, it
presentation?
is. Yes, it is.
Good afternoon, all. I'm Bhagyashree, and I'll be presenting my paper on assessing ECU vulnerabilities. Actually, we are trying to implement bus of attacks on an automotive CAN network by assessing the vulnerabilities that are there in the automotive CAN networks. So going through the agenda, I'll be first covering what the introduction to what is an ECU and what is CAN, and then I'll be going through the layered methodology that we have used to assess the vulnerabilities, and then finally we have the experimental setup and implementation of the bus of attacks, attack demonstrations, which are some pictures, and mitigation for the whatever attacks we have mentioned. So if we get into the electronic control unit of any automotive vehicle, we'll be able to see the software components as well as the hardware components in it. The hardware components include the memories and the microcontrollers, communication interfaces, other management power management ICs, and then sensors. Then the software part may include the real-time operating system. It may have the middleware, firmware, and it may have the bootloader or the diagnostic and debugging part of it. So moving through this, if we talk about the CAN as a network, these different nodes that are connected onto a vehicle, they are connected on a single bus. It is like a backbone structure, and the features of CAN communications are like it is a robust kind of communication, as well as it has many like loopholes in it, because it is a broadcast kind of communication. There is no security involved in it, but it's a robust kind of communication, and fault confinement is also good in this. So if you look at the CAN frame, you will be able to see the error detection and error acknowledgement bits in this, but there is no chance of, or there is no space for any authentication or encryption in this. So whenever a sender and the receiver, sender is sending the data and the receiver is receiving it, all the other nodes also read this data and they try to process this based on the message IDs. So there is no protection involved in this communication. So hence it becomes easier for the attacker to sniff the data and perform any particular kind of attack. So to find out the vulnerabilities of this, we have found out a 3-layered approach here. Like first, in the first layer, we have the input sensors, other communication interfaces, and wherein the data passes through the ECU for the processing. Middle layer is the ECU layer. It might have different memories. It might have different controlling logics. It may have bulk of processing. So this becomes another attack surface. Next, the third layer is the output layer, where we have the actuators in place. So here also integrity here determines whether the commands are trustworthy or not. So this is again a layer of the attack surface for us. So in 3 layers, we have found out or assessed different vulnerabilities which are there, and which are the doors for or allow the attacker to attack the system. So what kind of vulnerabilities are typically there in each kind of layer? If we talk about the input layer, the attacker may perform this sniffing kind of attack, or denial of service kind of, or replay attacks, wherein at the communication level, the communication protocols that might be used here are CAN, SPI, I2C, or UART links. At the ECU level, we'll have the vulnerabilities like third-party libraries that are used, like if there are any driver flaws or any buffer overflows or heap overflows, this can also act as a surface for the attack. And finally, we have the output layer, wherein these are the actuator layers, the same kind of attacks that are performed on the input layer, same kind be used here also to take out the data or have an unauthorized entry into it. So based on these vulnerabilities, we have tried to implement these kind of 4 attacks, that is DOS, man in the middle attack, bus of attacks, and spoofing injections. So of this, bus of attack is one of the DOS attack only. But the thing is, it is a most dangerous kind of attack, because in this, the ECU gets switched off from the communication, because it feels like it is getting into error detection or recovery mode. So we have built a small network of 3 nodes, basically. So each node receives a kind of message ID. Each the network consists of the nodes, like we have used Raspberry Pis with CAN controllers with it, and the message IDs that we have used here are like 100, 200. So we have fixed these message IDs, and in the sender and receiving logic, in the sender logic, we have periodically broadcasted the messages in this network, and in the receiver side, we have implemented these particular messages are received by the receiver, and if the message ID matches with the message ID which the node is supposed to receive, then the node will process that particular message. So the bus of attack happens through spoofing. One of the attacker nodes spoofs the data, and it starts flooding the bus with multiple messages with these legitimate IDs which it has sniffed. And finally, the victim node will, after the error counter reaches a certain value, that is 255, it gets into error passive state, and it gets detached from the network. So this is a state diagram which shows how like there are error counters which are there at each nodes, sending and receiving, for the sending transmission reception to happen properly. There are counters that are mentioned, that is transmit error counter and receive error counter. So there are three states: error active state, error passive state, and bus off state. A node enters into these states before entering into bus off state. If the error transmit error counter is greater than 255, it enters into a bus off state. So this is a Linux-based ECU network with Raspberry Pi. We have set up a 3-node network, and in which one of the node is acting as an attacker node, and different kinds of attacks have been performed on the network. We have tried to flood the network with multiple messages, and we have tried to do the attack implementation. So this is why passive sniffing is actually dangerous. Because CAN is a broadcast kind of network, each particular message is received by all the nodes. We never know which particular node is actually trying to sniff the data and flood the bus with multiple legitimate CAN messages, and then it may make the victim node leave the communication. So in the conclusion, we have implemented a 3-layered methodology for assessing the vulnerabilities. So 3 independent with different Raspberry Pi nodes, we have implemented the network. We have implemented DOS flooding, bus off attack with spoofing, and also this approach generalizes throughout the hardware, confirming its value for engineers and researchers for the further. So next we are planning to implement it on different kinds of protocols, integrate it with HIL so that we can understand the procedure better, and work towards a holistic next generation automotive security assessment pipelines. So these are the references. So thank you. Shall I stop the sharing?
Yes, you may. If there's any questions, so you may ask.
Yes, should I ask?
Yes, sir.
Yes, Bhageshri, good presentation.
Yes, thank you.
You said about spoofing, isn't it?
Yes, sir.
So can you tell me which there are different type of spoofing. Which type of spoofing you are considering in your
Sir,
research?
we have spoofed the message IDs, sir.
Message IDs.
Yes.
Achha, achha. Okay. Okay, fine. It is
Yes.
all from mine.
Yes.
All right. We'll now move on to the next presentation. Just a moment. Right. So the next presenter is Namrata Jangam, who will be presenting Aura L, a novel adaptive framework for robust driver drowsiness detection. Namrata, you may now begin. Is Namrata or any of her co-authors present in the meeting? All right. So in that case, we'll move on to the next presentation. Our next presenter for today is Yashika Sharma, who will be presenting Green Technology and the Energy Complexity of an Algorithm. You may now begin your presentation.
Good evening, ma'am. Am I audible?
Yes, you are.
Is my screen visible, ma'am?
Yes, it is.
So good evening. This is Yashika Sharma presenting Green Technology and Energy Complexity of Algorithms. This paper is basically emphasizing on all the factors that affect the energy efficiency and carbon footprint that is impacting the environment, and that is emitted by the computing devices, and how we can cope up with or improve the energy efficiency and reduce the carbon footprint. So here we go. What green IT is. Green IT is all about a sustainable design. In terms of hardware and software, wherein the minimal resource footprints from the initial stage only, from the conception of the design only, we focus on how to reduce the carbon footprint. There are various options that will be discussed in later slides. Eco operations, we need to focus on the algorithms that are more energy efficient so that uh, less power is consumed and less is the power carbon footprint impact. A responsible end of life, implementing a circular economy principle, that is we need to reuse, reduce and recycle principle. There should be options to recycle the equipment so that the e-disposals is least. So this is the life cycle of a typical computing device. It starts with the designing process. After finalizing the design, the manufacturing, then packaging, distribution, use, and finally the disposable. So at every stage, we have a scope of improving a bit, because a single bit counts. So we have scope of improving certain factors so as to reduce the carbon footprint and improve the quality of the environment and moving towards sustainability. So the first stage is design. We can use energy efficient CPUs, replaceable components. Rather than discarding the complete system, the components can be replaced. Manufacturing, carbon neutral factories should be established, and we should invest more into green materials rather than the contemporary materials that we've been using for ages. Comes the usage. In server the servers actually contribute the most towards the heat and the most power consuming component. We can reduce the heat produced and the power utilization by the concept of virtualization, and that too using virtualization as a hardware and software. Green coding, that means using the algorithms that are more energy efficient in terms of time and space complexity. disposal, there should be norms for proper disposal. Yes, there are still norms, but they need to be strengthened, and proper disposal norm should come in place, and there should be a mandate on how much material is to be recycled and reused from the discarded computing devices. Then we have this energy versus complexity versus energy trends. So the energy of an algorithm is dependent on two factors: time complexity and space complexity. The overall complexity of an algorithm depends on the maximum of the two values, because the maximum superpowers the minimum value. If So here is a comparison of time and space complexities and can be explained with the help of this table. If the energy space complexity is less, but the time complexity is more of an algorithm, the overall impact is definitely more. So we need to choose an optimum algorithm for our networks that has an optimum space complexity and time complexity. The combination of both results in an efficient algorithm or a green algorithm. This again focuses on the hardware lifecycle assessment, an assessment where we actually have to put more effort to make computing a more environment friendly domain, which is not, though we don't it is not directly impacting, but yes, the heat and the power consumption definitely contribute towards the footprint. So this is how the manufacturing impact. It shows the laptop's lifetime carbon footprint is 70% of the laptop's lifetime carbon footprint is generated during the manufacturing and distribution phases, even before it is powered on. So there needs to be a substantial effort on the manufacturing and designing and distributing part to limit the carbon footprint that is given by this IT industry. We can also focus on lifespan extension of the IT devices from 3 to 5 years, because longer the usage, lesser will be the production and lesser will be the carbon footprint. There are options for optimizations, hardware optimizations, efficient processor. We can use multi-core scaling, improve and improved performance per watt architectures. We can have server virtualizations, VMs can be used, dynamic cooling, AI driven so as to lessen the heat produced by the server uh, chambers. Then we have sustainable software devices. We can use efficient languages. Compiled languages definitely have an edge over the interpreted languages because they take less time to get executed. We can use the cloud services or the cloud providers which use 100% renewable energies. Redundant data can be minimized, because more the data, more the bandwidth used, more the energy is utilized. So redundant data definitely counts for the energy consumption. Now, this is the daily energy saving impact. Even the smallest step of ours can definitely result into a more sustainable and more beautiful environment world. Well, it's a general trend that we keep our systems on, we leave them as it is. We don't pay a much attention, but this it does make quite a big impact on the environment. When your system is in full active power, 100%, display only off, we hardly make it a point to put it on a hibernate mode or a sleep mode, though the difference is substantial. With every counting device, with every device, if this difference is counted, the impact is definitely huge. So we can have, there are several ways we can make it a sustainable domain, whether it's a hardware, software, but the actual impact starts from our own daily practices, so as to reduce the total carbon footprint and make IT and environment friendly domain. Thank you.
Hi, Yashika. Hello, I'm audible.
Yes, sir. Yes, sir.
Hi. Uh, you are saying sustainable IT, green technology, right?
Yes, sir.
What data is supported means whatever you are saying, it should be supported by data, then authenticity of data. Can you put light on it?
Sir, I have actually gone through papers, literature survey, and these are the basic factors. These have been, some may be estimation, some are established facts, right? And green IT definitely, the data is what we have achieved in like we actually I couldn't mention here. There is a relationship between the energy efficiency and the bandwidth usage and the threshold of an algorithm, and an algorithm depends, the efficiency of algorithm depends on time and space complexity. So they are actually somewhere associated with it mathematically. They are definitely dependent on the energy efficiency of an algorithm, definitely dependent on this power consumption and bandwidth usage.
But that is the concept, whatever you are saying. I am saying evidences or supporting data for these statements from where you are taken.
Sir, this is from the previous literature survey. Actually, this is a base paper before, just to identify the problem for further futuristic work to be done.
Acha. And the topic is good, but the things which is to be said and concluded should come with the standard set of information. That is the only thing.
Right,
Okay,
sir.
fine. It is all from mine.
Thank you, sir. Thank you.
All right. Now we'll move on to the next presentation. And next up, we have Ashish Das, who will be presenting hybrid deep feature extraction and maximum margin learning for automated PCOS diagnosis. You may now begin.
Thank you. So let me share my screen. Just a second. Yeah, I guess my screen is visible.
Yes, it is visible, Das.
Yeah. Good afternoon, everyone present over here. I am Ashish Das of Sambalpur University Institute of Information Technology, presenting my paper on hybrid deep feature extraction and maximum margin learning for automated PCOS diagnosis. Let us move towards the introduction section. Uh, yeah. So PCOS or polycystic ovary syndrome is one of the most common endometric disorder affecting women of reproductive age worldwide. It is associated with several health complications, including hormonal imbalance, ovarian dysfunction, infertility, insulin resistance, obesity, and metabolic disorders. If left undiagnosed, it may increase the risk of developing type 2 diabetes and cardiovascular diseases. Therefore, early diagnosis is crucial because it enables timely treatment and helps prevent long-term health complications. In clinical practices, PCOS is primarily diagnosed using ovarian ultrasound imaging. However, the risk assessment is performed manually, making it time consuming, highly dependent on the clinical expertise. These limitations motivate the need of more reliable and automated approach for PCOS diagnosis. Let us move toward the motivation of this work. This work is motivated by two major challenges. Okay, the first current diagnostic of PCOS is using the Rotterdam criteria relies on the manual ultrasound assessment, which is time-consuming, subjective and prone to human error. The second, although the deep learning models like ResNet, VGG achieve a high accuracy, they are computationally expensive and not suitable for portable or point of care clinical device. Therefore, there is a need for a lightweight, efficient, and automated PCOS detection framework. Okay, now we will go towards the literature part. So, as you can see, this table summarizes the existing PCOS detection methods. Most studies achieve high classification accuracy. However, each has significant limitation. Ensemble and hybrid model suffer from high computational complexity, while deep architecture such as Inception V3 and CNN transformers models are computationally heavy. Some lightweight approaches lack real-time deployment, whereas others rely on clinical metadata instead of ultrasound images. Therefore, there is a need of a lightweight model is required. Now moving towards the research gap. So based on the literature review, we identify a clear research gap. Existing PCOS, that is existing PCOS method, either rely on computationally expensive deep learning model or do not evaluate robustness under real world conditions. Therefore, there is a need of a lightweight, accurate, and robust ultrasound-based diagnostic framework that is suitable for practical deployment over deployment. Our proposed hybrid MobileNet V2 SBM framework is designed to address this gap. So moving towards the data set. So for this study, we have used a publicly available PCOS ultrasound data set from Kaggle. The dataset contains two balanced classes, healthy ovaries labeled as non-infected and PCOS affected ovaries labeled as infected. To improve the image quality, we applied multi-scale Retinex for contrast enhancement, and all the images were resized to 224 cross 224 pixels. Finally, the data augmentation technique such as rotation, scaling, and flipping were used to expand the data set and to improve the model's generalization performance. Now we will move towards the proposed methodology. Okay, the proposed framework begin with the pre-processing of the ovarian ultrasound images using resizing, normalization, and MSR enhancement. The data augmentation is applied to improve generalization. MobileNet V2 is then used as a lightweight feature extractor to obtain the deep feature representations. To evaluate the robustness, the stochastic feature extraction through the feature of Gaussian noise is introduced. Finally, the linear SBM classifier predict whether the ultrasound image belong to the PCOS or healthy class. So coming to the result section, the performance of the proposed hybrid MobileNet V2 SVM framework as shown in the confusion matrix, the model correctly classified most of the PCOS and healthy ultrasound image, achieving an overall accuracy of 98.24% with a few misclassifications. The ROC curve shows an AOC approximation 1.0, indicating the excellent discrimination between the two classes. These results demonstrate that our framework provides accurate and robust PCOS detection with low computational cost. Okay. So at last, I will finally conclude my session. Finally, I would like to conclude my paper by saying that we proposed a lightweight hybrid MobileNet V2 SVM framework for automated PCOS detection. The proposed model achieved 98.24% accuracy while remaining robust and computationally efficient, making it suitable for real-time clinical application. Thank you for your attention. If you have any questions, I am feel free to ask you.
Hello, Ashit Das.
Hello, sir.
I'm audible then. You are saying about a hybrid deep feature, isn't it? Why it is called as a
Yes, sir.
hybrid? Why it is called as a hybrid?
Because we are integrating two different models here. So for the data extraction, for the feature extraction, we are using MobileNet V2. Okay, so it's a lightweight model. So it has over less than 5 million parameters are present over there. And for why it is called as hybrid, because we are um, mixing two, actually we are mixing two different model. Let's suppose we are
But
taking the
yes, Das.
yes,
But we are taking it sequentially. It is not parallelly, isn't it?
you can say, sir, like that.
But if it is sequential, then how it can you can say that it is a hybrid?
S- if it is yeah, you are
You are
correct,
using.
sir.
You can say that you are using multiple algorithm. That is fine.
Yes.
But why it is called as a hybrid then?
The word hybrid itself only means that um, where two or more models are integrated into a single model, then it is it
Acha,
will go for a
that's fine.
hybrid.
Okay, that's. And then you are saying that already 98% percent accuracy you got, isn't it?
Yes,
It is
sir.
available already, isn't it? So
No, sir.
whatever develop
We got actually.
you got it earlier. How what
Yeah.
it is? What was
So,
it
sir,
is?
earlier there are lot of models are there, but they are computationally heavy, sir.
Acha,
So,
because I have seen
yeah,
accuracy more than that also.
yeah. There are models,
Acha.
but they are
Hmm.
computationally heavy.
No, but
But
again,
in our case, the entire model is around less than 5 million parameters.
acha, fine. But 98% is a means it is. I think it is overestimated accuracy. That is fine. But as you are saying that it is supported by experimental result, then it's okay, fine. Okay, it is all from my end.
Thank you, sir.
All right. Our next presentation for today will be by Lakhe Vaishnavi Sudharkar, who will be presenting just-in-time explainable AI for real-time detection and prevention of phishing and smishing attacks. You may now begin.
Is my PPT visible?
Not yet.
Yes, it is. No, it is not visible. The ICT symbol I was able to see. I thought it is a PPT only. Fine.
Is it now?
No, it is not.
Please try resharing.
Is it visible?
Your screen is visible.
Good evening, everyone. Myself, Vaishnavi Rakhe, will be presenting on real GIT XAI, real-time explainable AI for just-in-time phishing and scam intervention. Nowadays, there are online fraud and scam are increasing rapidly. Many people lose their money because scammers create panic and convince people to share their sensitive information, OTPs, bank accounts, or bank details, or passwords, etc. Like true callers, where I have seen hello, am I audible?
Yes, you are.
Can I start?
Yes, please.
Okay. Nowadays, there are online frauds which ask for OTPs and phone calls, phone passwords, and etc. Uh, which makes in panic, people get confused and share their information without thinking and any if it is a fraud call or anything. Uh, my app tells whether the phone call is fraud or not, and explains the reasons why the app is why the call is fraud with the reasons. Okay. Uh, the biggest challenge is that people realize they were scammed only after transferring money. Existing applications mainly detect scam numbers but cannot understand live conversations. Our goal is to provide a warning before the victim takes any wrong actions. If someone says you my app works like if someone says your phone account will be blocked today, share me your OTP immediately. Our system detects words like OTP, block, or immediately, and warns the users. Um, our first objective is to detect scam calls before the user becomes a victim. Uh, instead of giving it the informations. Another objective is the transparency. The user should know why the scam instead of blindly trusting the system. I used the LSTM model for that, and analogy for English translation. Uh, there is also consent pop-up for recording the voice or the messages and it is also used during the offline if the phone is offline. Methodology. Our project works in several steps. First, the Android application records the conversations uh, after taking user's permission. Then speech is converted into text. Every 10 seconds, the text is sent to our backend server. Uh, the server processes the text and extract important features. These features are given to LSTM model. The model predicts whether the conversation is genuine or fraud. If the scam probability crosses the threshold, the explainable AI model identify suspicious words. The threshold for my model is 0.6. If the threshold gets more than this, then it generates a pop-up message that this phone call is fraud, and be aware of it. Framework for my project is first the call or SMS input, then the text processing is done. I use the scam detection model, which detects the words which indicates whether the call is fraud or not, and then an explainable AI for which give the reason why the call is or maybe a fraud call, and user warnings is generated. Data processing to raw text contains punctuation, symbols, extra spaces, and unnecessary words. This increase the noise. So we clean the data before training. This improves prediction accuracy and helps whether the call is to analyze whether the call is a fraud or not. Feature engineering. Here I used a TF-IDF vectorization for the words, where the urgency keywords score and financial keyword scores and thread terms are generated by using different words like urgent, right now, OTP, bank number, bank account, credit card number, etc. Tokenizations. The tokenization is done for the words, and the sequence is done, and there is padding for the words using the LSTM. The sharp features like financial keywords like bank account, OTP, credit, etc. Urgency indicator, which shows urgent immediately, uh, as soon as possible, etc. And third threat term like suspend, block, illegal, etc. And message length of usually long messages is predicted, and has which has special characters, etc. And the example of my output is that if a scam is done by example OTP and immediately, etc., shows the scam 92%.
Excuse me, I'm so sorry to interrupt. You have a minute left.
Okay. The advantages of JIT XAI is it is a real time and provides the explanation whether the call is suspicious or not, and it also works in offline and gives the reasons for the call is fraud or not. And implementation of this is Android and backend. We use caller receiver KT and over overlays service for pop-up messages and ringing the whether the phone is ringing or not indicated. limitations. It is only Android based, not iOS, and it is only based on English text. So it may need maybe need of English, Marathi, other languages also. Conclusion: it is built-in real-time vision detection system with explainable AI, 94% accuracy, 93.8% precision, and 94% recall. AUC, ROC for 0.98. Thank you. Hello.
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 Yes. You said about wishing attack and SMSing attack, isn't it?
Yes.
But SMSing attack, I am not able to see.
The fraud messages that comes. It detects whether the message is fraud or not.
Go to that slide. Acha, have you used any relevant or benchmarking data set for SMSing?
No. I've
Acha,
used the available data.
acha. That's fine. It is a good study. It is all from my end.
Thank you.
All right, we'll now continue with the next presentation. Our next presenter for today is Kizumo Talani, who will be presenting Security and Privacy Challenges in IoT Data Protection, a technical review and framework development. You may now begin your presentation.
Hello.
Yeah,
Hello.
audible.
Okay. And is my screen shared?
Yes, it is.
Okay, fine. Thank you very much. I'm Chisomo Tolan from Malawi, and I'm here in India as a research scholar at Gujarat University. And my paper, which I'll be presenting today, titled is Security and Privacy Challenges in IoT Data Protection, a technical review and framework development. The Internet of Things, commonly known as IoT, has become part of our everyday lives. We now rely on smart healthcare devices, smart homes, industry automation, transportation systems, and smart cities. So while these technologies provide enormous benefits, they also collect massive amounts of personal and sensitive information. Unfortunately, current security and privacy mechanisms have not evolved at the same pace as IoT technologies. So this study therefore investigates the major security and privacy challenges in IoT environments and try to propose a comprehensive framework that integrates technical security, privacy protection, and governance throughout the entire IoT life cycle. Before discussing the solutions, it is important to understand. Why IoT presents unique security challenges. Unlike traditional computer systems, IoT consists of thousands or even millions of interconnected devices. So these include sensors, cameras, wearable devices, industrial machines, smart vehicles, and medical equipment. So these devices continuously collect, process, and transmit data without human intervention. So this data, uh, which is collected, may include maybe personal identity, location, health conditions, uh, daily activities, financial information, and behavior patterns. So if attackers gain unauthorized access, they can monitor individuals, manipulate devices, steal confidential information, or even disrupt critical services such as hospital, uh, power grids. So therefore, protecting IoT data is not only about confidential, but also about public safety, trust, and national security. Uh, Although many security solutions already exist, they do not fully address IoT environments. Like first, the first challenge is of resource constraints. Many IoT devices have very limited processing power, memory, and battery life, making it possible to implement heavy encryption algorithm. And second, IoT environments are highly decentralized. Different organizations manufacture devices, provide cloud services, maintain networks, and manage applications. So this makes accountability difficult. And thirdly, regulations such as GDPR provide excellent legal principles, but offer little practical guidance on how these principles should be implemented on resource constrained IoT devices. And we can see that existing research, uh, we have noted that existing research tends to focus on isolated issues such as authentication, encryption, or access control, instead of providing an integrated end-to-end solution. So these limitations motivated this study. So this study contributes to the existing body of knowledge in several important ways. First, we have conducted a structured analysis of the most common IoT security threats, including device vulnerabilities, communication attacks, interference attacks, and privacy risks. And also, instead of studying isolated stages, we have examined the security across the complete IoT data lifecycle, from data generation to final deletion. And we have mapped the legal privacy requirements to practical technical controls, helping bridge the gap between regulations and implementation. So most important, we have proposed a unified layered framework that combines technical controls, governance mechanisms, and adaptive security suitable for heterogeneous IoT environments. So the framework proposed here therefore addresses both technical and organization aspects simultaneously. In this study, we have adopted a PRISM systematic literature review methodology. We have adopted this because we wanted to provide a transparent and reproducible approach for selecting relevant literature. So we searched the major scientific databases using keywords such as IoT security, IoT privacy, data protection, data governance, and IoT security framework. And initially, we identified 140 studies. And after removing duplicate papers and applying our inclusion and exclusion criteria, only 20 high quality studies were selected for detailed analysis. And on our findings, we identified 4 major categories of vulnerabilities. And the first one is device security. Many IoT devices still use default passwords, outdated firmware, weak authentication, and insecure boot mechanisms. And the second category is network security. Communication channels remain vulnerable to eavesdropping, replay attacks, spoofing, and distributed denial of service attacks. And the third one is data processing. As we know, cloud platforms often suffer from poor access control, insecure APIs, and extensive data collection. And finally, the privacy risk remains significant. Even when data is anonymized, advanced analytics can often re-identify individuals by combining multiple datasets. So this demonstrates that encryption alone is insufficient for protecting privacy. So I can say one important objective of this study was to identify some of these research gaps. It has been noted that most existing studies solve only one part of the problem. Some focus.
Excuse me, I'm so sorry to interrupt. You have 1 minute left.
Oh. Okay. So let me fast forward to the proposed framework. So our proposed framework consists of 5 interconnected security layers. Layer 1 focuses on securing IoT devices. Layer 2, communication networks. And layer 3 manages secure data storage and processing. Layer 4 provides identity management, authentication, authorization, and trust management. And layer 5 addresses governance, privacy compliance, auditing, and regulatory requirements. So we can see that unlike existing models, these layers work continuously rather than independently. So as data moves through the IoT ecosystem, every layer contributes to protecting it. This creates defense in depth while maintaining flexibility across different IoT environments. So to conclude, because I don't have time, the study demonstrates that traditional security approaches are insufficient for today's IoT ecosystems. IoT requires an integrated approach that combines technical security, privacy protection, governance, and regulatory compliance. So the proposed 5-layer framework provides a comprehensive protection throughout the entire IoT data lifecycle, and it addresses the many shortcomings identified in previous research, while remaining practical for resource-constrained environments. However, this work is not the final step, as the framework has not yet been empirically validated, and it requires future research for practical implementation in fields like smart healthcare and industrial IoT. And also, additional work is also needed to improve interoperability across different countries and regulatory frameworks. And in summary, the framework provides a practical foundation for building secure, privacy preserving, and trustworthy IoT ecosystems. Thank you very much for your attention.
Hello, Mr. Tolani. Hello, sir. Am I audible?
Hello, sir.
Acha. Now, throughout your presentation, you said about privacy in IoT, isn't it?
Yes, sir.
But if you're saying privacy, then privacy it does have its own different verticals or different categorization. I have not seen that categorization in your presentation. Can you say something on that? Hello.
Hello, sir.
Privacy categorization.
IoT privacy categorization.
Can you say about this?
Okay. On that one.
Privacy categorization.
Yes, that one I was trying to say, like information privacy, data privacy. Yeah. This one, this concerns the protection of personal and sensitive information collected, processed, stored, and shared by IoT devices. Like, for example, sir, person identification data, health records from wearable devices, financial information, smart home usage data. And this information, there are some privacy threats that are targeting this. And this may happen if there is unauthorized access, data breaches, excessive data collection, and data sharing without consent. So to protect this, there is a need for protection mechanism. So that's why we have proposed that framework whereby it is consisting of the 5 layers. And in those 5 layers, there is encryption, access control, consent management, data minimization, sir, and privacy by design, sir.
Acha. Okay, fine. It is all from my end.
Okay, thank you, sir.
All right, we'll now move on to the next presentation. And our next presentation is by T. Sai Sushant, who will be presenting VNR ACE, a unified agenting campus ecosystem. You may now begin your presentation.
Hello. So, am I audible?
Yes,
you are.
Yeah, sure. Okay. So, let me introduce to our problem statement before diving into our application. So, as we all know, like the AI is being, trend over the society. It's being incorporated in all the big companies for various tasks like automations, code generations, etc. and all. So, and one of those trending topics in AI is the agentic AI. Which is basically how does an agent different from a general LLM? It is trained and made especially to perform a particular task in a precise way, and so it's like a human being employed for a particular reason. The same way the agents are built, and this agentic AI is like the boom in the industry, being incorporated for various code generation tools and in many other companies and in many other areas. So as a student, like we saw an application of it towards applying it for an education institute level purpose, where you can automate numerous numerous tasks which are being done manually, and you can just automate them and improve the efficiency of the institutional processes, admission processes, placement processes, and help students a lot in getting a better experience throughout journey. So that was like a brief problem statement of how, like, what is happening and all. And let's say as it is in trend, so there are applications and of these which are already tried out and tested out by many universities, and they've submitted their research. Out of all these, what are the common observations what we have was, let's say most of them were especially designed for a particular, only a specific aspect of their institution, not just the entire process. Or few of them were not unable to scale it up and maintain it properly and all. So most of them were like the theoretical approaches of how we can do it. So we tried to fill the gap by building this as a whole ecosystem rather than a simple individual module. So when I say ecosystem, it covers each and every process, including from the admission process till the students get placed in their they finish their curriculum and placed in a job or anything. So how is it different from the existing ones? Then I'll just say the one I just mentioned, key, it is like an ecosystem where there are multiple agents talking to each other and performing tasks and all. So here we have three different modules on our high level, which separate module for the admissions and the one for the placements and one for the during classwork. So admission agent is like targeting the you know the initial query process, like the users need to let's say search the Google or know about the college, but they don't know how to get the correct information, or and they even feel like visiting out campus or in person to get the feel of a department person speaking to you. So our custom trained agents will talk to the parents or the students as if they are the expert in the particular department and answer their queries. So this just gives them a more confidence in the college and all. Then coming to the placements, it covers a wide range of features like application portal and helping students to improve their resumes, and helping the TNP department to shortlist their resumes based on the job descriptions instead of random GPA criteria, which is the like, general approach going on in most of the colleges. So and the classwork agent is helps them in finding the faculty details and all throughout their journey. So our study is basically more on application focused. So we just try to build out a complete ecosystem which with multiple agents speaking to them. And the key distinguishing factor here is you have a human in the loop for monitoring and approvals, because you can't completely rely on AI while it comes to matters of education institutions, health or something. So one of the key important factors is the human in the loop concept, which we incorporate, and role based access. So this allows us to develop a complete ecosystem which we can utilize, which we can provide students and the institutions to improve their overall experience of their time studying there. So, yep, that was like all about our application. Like, we are open to questions if any. Hello.
Sir, do you have any questions? All right, in case there's no questions, we'll move on to the next presentation. Let's circle back to a presenter that we had missed. Just a moment. All right, so if Namrata Jungman or any of her co-authors are present today, we'll be taking Aura L, a novel adaptive framework for robust driver drowsiness detection. All right. In that case, we'll move towards the closing remarks. Just a moment. Okay. So I would like to end the session by sincerely thanking all of our authors for their excellent presentations and contributions in this session, and all of our participants for being a part of this international conference. I hope this session was informative for everyone, and on behalf of the entire team, I thank you for your support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates via email within the next 2 working days. The publication will be live in 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. I also thank our session chair, Dr. Shafi Pathan, for chairing the session. I would like to present a token of appreciation to the chair on behalf of Team ICT4SD 2026 and Global Knowledge Research Foundation and partners. Thank you so much for your valuable presence, sir. Before we end the session, I would like to request everyone to please turn on their cameras for a quick virtual snapshot. All right, thank you so much, everyone. The session is adjourned.